Hello, this is Mr. Waitman. This is the second video in the Stoichiometry series, applying that mole ratio. In a previous video, you learned about the graphic organizer up, over, and down. In that video, you learned about the step over, which was really just looking at the relationship or the ratio between the various substances within a balanced chemical equation. In this video, we'll examine the up and we'll look at the down. And this is really just the mathematical processes that you need to apply to a given amount of a substance so that you can determine the outcome. Imagine this scenario. 5 moles of methane were combusted with excess oxygen. Right away, there's something new that's being introduced here. This is the piece of excess, which means lots or more than you need. Excess oxygen means this is not limiting the reaction of the other reactant, in this case methane. Determine the number of moles of water that would be produced in the reaction. Well, first off, we need to look at the actual reaction as a chemical equation. So here we see methane, oxygen, producing carbon dioxide and water. But we notice that it's not balanced. In all stoichiometry, the first step is always to balance a chemical equation. So once we balance the chemical equation, we see it looks like this. Again, we could look at the ratio. We have, for every 1 methane, we require 2 oxygen, and that would produce 1 carbon dioxide and 2 waters. So let's write down what we know. We know we were given 5 moles of methane. That's important. We want to use this up, over, and down, but now that we're getting away from a simple question that just used the actual ratio, if you had 1, how many would it produce? Now we're given an actual amount of the substance. So in this case, we have 5 moles of methane. The expression that I use is divide where you start and multiply by where you're going to. So in this first step, divide by where you start, that just means that you divide by the coefficient that is found in front of that substance. So really we're saying for 5 moles of methane, divide that by 1 mole of methane. This might not seem significant while the coefficient is 1, but when it is a number other than 1, it becomes quite significant. If you get in the habit of doing this as each step, you'll find that it has great reward. So again, you multiply where you finish or where you're going to. So in this case, that's the coefficient 2. So you're multiplying by 2 moles of H2O. So what we're really now finding out is our moles of methane both cancel out, so we end up with 10 moles of H2O as our final product. Let's do another problem. When nitrogen gas reacts with hydrogen gas, ammonia is formed. If you were asked to determine the number of moles of ammonia produced when 6 moles of hydrogen gas reacts with excess nitrogen, you'd need to go through the same steps. First, we look at the reaction. Then we balance the chemical equation. We all know the next step is to record or put down what we already know. In this case, it's 6 moles of hydrogen. Let's get rid of the problem so we have space to work. So we've got 6 moles of hydrogen gas. We're going to go through that process of up. You'll recall that we divide where we start and we multiply where we're going to. So let's divide by the 3 moles of H2. Now we're going to go over to where we want to calculate a product. And here, this is the down. We multiply by where we're coming out. Now this works both directions, not just from reactants to products. You could also do this products to reactants. So now we do the math. Our 6 divided by 3, canceling out the units here. 6 divided by 3 would be 2, and multiply that by another 2 would give us 4 moles of our ammonia. The teacher is going to want to pause the video now so that you can have a chance to do the following question. I'll put the answers up once you're done. When you unpause the video, the answers will be there, and then we'll let you move on to the next video.